Hi, welcome to Fun with Algorithms. In this video, I'm going to introduce you to dynamic programming and how to optimize calculation of Fibonacci number using it. This is going to be the first video of a series in which I discuss various patterns of solving variety of dynamic programming problems. Please do hit subscribe button to receive notifications on new videos in this series. Now let's look at what dynamic programming is. So dynamic programming is just a technique to reduce running time complexity of an algorithm. Now, if you want me to make a video on time complexity of algorithms, please do leave a comment below. But to define it in a crude way, time complexity of an algorithm is just how quickly an algorithm completes. Now, coming back to dynamic programming, before we see what it is, let's first understand when to apply dynamic programming. So there are mainly two characteristics which if a given problem exhibits, then there is a very good chance that we could use dynamic programming to optimize it. And they are optimal substructure and overlapping subproblems. We will see what each of these means with the example of Fibonacci number. As you may know, Fibonacci number of an integer, say n, is calculated by adding Fibonacci numbers of n-1 and n-2 with the base case is that for both integers 0 and 1, Fibonacci number is 1. We will first look at the straightforward approach of implementing this algorithm using recursion and then analyze whether we can optimize it using dynamic programming. So this is the basic implementation of calculating Fibonacci number using recursion. Here I would like to bring your attention to the line where we are calculating the result. So if you see, we call the same function we are executing currently, but for smaller numbers. That means we are reducing the problem size from n to n-1 and n-2. But algorithm we execute on smaller problem size is same as what we are executing currently. So this is our first characteristic, that is optimal substructure. So a problem is said to have optimal substructure if we can construct optimal solution or best solution by calculating optimal solutions of its subproblems or similar problems of smaller size, which is what we are doing in calculating Fibonacci number. Now, to understand what overlapping subproblem mean, we will take a look at recursion tree of Fibonacci method for number 5. So these are the different calls recursive method we saw before makes to finally calculate Fibonacci number for integer 5. It first calls the same method for numbers 4 and 3. Now again number 4 calls it for numbers 3 and 2 and so on. So if you observe, same method is called for number 3 twice, doing all the calculations till the base case is hit. Similarly, same method is called for number 2 twice. This is what we call it as overlapping subproblems, as same problems are being calculated or executed multiple times. So now this might look insignificant for this example because it is a very small example, small problem size. But if you are calculating Fibonacci number for say a number like 2 million, then it would just blow up. So to solve this problem, if we store computation of any subproblem in some way and just reuse it the next time we encounter it, then we avoid so many calculations. In fact, for this problem of calculating Fibonacci number, we actually reduce the time complexity from O of 2 to the power of n to O of n. That's a huge improvement. So now by using this technique, our recursion tree reduces to this. Wow, this is great, right? Now if you see, we are calculating Fibonacci number for 3 only once and return the already calculated result or calculated value next time when we need it. Same thing is done for Fibonacci 2. Alright, this is great, but how do we actually implement it? Now for this, there are mainly two ways in which we can implement dynamic programming technique. First one is top-down method or memoization, and the next one is bottom-up method or tabulation. We'll first look at how to implement Fibonacci method using top-down method and then look at bottom-up method. So in top-down method, we first try to solve the bigger problem, but by identifying its immediate subproblems and solve those subproblems. This identifying happens at each step and we store these calculations somewhere so we can reuse them. Now in this code we have here, we use an integer array named temp to store results from subproblems. First we check if we have already calculated the value for a given number, and if so we just return it. Else we calculate the result, store it in temp array and then return the result. We call it top down because we first try to solve the bigger problem and then dive into smaller problem as and when we need it. But in bottom up method it's different. Here also we store result in some temporary location. Here it's a temporary integer named temp, but we first calculate results for smaller subproblems directly and store its results in this temp array. And then we calculate results for its immediate bigger problem and use the result we just calculated before. So if you think about it, we do our calculations from smaller problems or bottom level problems in the recursion tree we saw, and then move to bigger numbers and finally calculate the result we want. So that's the introduction to dynamic programming and different ways we can implement the dynamic programming problem. Now, if you like this video, please do like, comment, share and subscribe. And don't forget to press the bell icon to receive notifications on my new videos. See you next week. Thank you.